So, okay, we can start. Um, Hello, everyone. Today, we are diving into the solid principles, the foundation of clean, scalable, and maintainable code. These principles introduced by Robert C. Martin, aka Uncle Bob, yes, in the 1990s, are essential for building robust software systems. By the end of this session, you will understand how to apply these these principles to write flexible, future-proof code. And let's start it. Yes, we can. Let's start. Okay, the main goal it's solid is acronym represent five five key principles of object-oriented design. The five This five principle is single responsibility principle (SRP), open closed principle (OCP), least code substitution principle (SP), interface segregation principle (ESP), dependency inversion uh, principle (DEP), and each letter in the solid is a first letter in these principles. Yes, and these principles help us design software that's easy to maintain, extend, refactor without introducing unexpected errors, bugs, etc. Let's them down one by one, starting with SRP. So the single responsibility, the first key principle is first single responsibility principle. The SRP states that a class should have only reason to change. The meaning it should focus on a single responsibility. The analogy you see, the think of a spurk, a spurk, a spoon fork hybrid. While it's versatile, it's not great at either task. Dedicated tools like separate spoon and fork work better. These dedicated tools, and the example is instead of monolithic patient class handling that data storage and report generation, we split into two main classes. Patient data model manages patient data, and reports generator handles report creation. And this make this split, this division, this make the code more cohesive and easier to modify and maintainable. And the next up, you see the OCP and the LSP, open closed principle. OCP software entities class modules should be open for extension but closed for modification. In other words, you should be able to add new features without altering existing working code. And the least cost substitution principle, subtypes must be replaceable for their bases. For the base types, you should be able to replace for example, coffee with cappuccino. Seamless, but replacing coffee with water would violate LSP if water doesn't support expected behavior like fraud. Uh, it is, yes, it is. So we can start the next principles. Yes, talk about the next principles. Uh, Finally, let's cover ESP and the DEEP. The interface segregation principle. Clients shouldn't be forced to depend on interface they don't use. Instead of one bloated interface, create smaller, the smaller role specific one. So you need to create a smaller and specific. It's necessary, and the dependency version principle, the deep uh, high level modules shouldn't depend on low level modules. Both should depend on abstractions. For example, interfaces and interfaces use interfaces to depend on abstractions. This reduces coupling. And why salt matters? Apply these principles to flexible, testable, and maintainable software architectures. It's the difference between spaghetti code, the smell code, and a well-structured system. I started using Solid today to build software that stands the test of time, and that's it. Yes, I think that's it. So yes.